kicks. Okay. At the UPS store, the clerk has received 3 packages from various customers as shown. Calculate the total weight of all boxes and the combined uncertainty. I have to say this, that the idea is that we're measuring everything individually and then we're going to add up the combined weight, all right? If you put all 3 of these on the scale at the same time, then we don't have to worry about the uncertainties combining, all right? So the idea is like we're doing this separately, and then we add up those weights, and then we have to account for each precision and uncertainty. So let's do that right here. I'm just going to do it. I'm going to deviate from my plan a little bit. The precision is, in this case, it lies right at the 5 here, which is 1 decimal. So that's my precision. Uncertainty is plus or minus half of that. I hope you can see that. And I'm going to cut this here. The precision for this box, I'm assuming it's 1 kilogram. Okay, 1 kg. And some of you already did this, so you just come along for the ride. Enjoy the show, guys. All right. So half a kilogram. This one has 2. I know that in reality it doesn't make sense, right? You're assuming the clerk would have used the same scale every single time, but we don't know. We just have to go by this. Here the precision is 0.01 kilogram because it's right there, right? It's the second decimal. That's where the precision, that's the limitation at that point. So it's plus or minus 0.005 kgs, okay? So if you can't see that, here you go. Just gonna have it sitting there for a bit. I'm interested in the uncertainties really, but you have to go through the motions of precision first, then the uncertainty. All right? I'll tell you this though, I'll give you a big heads up. Quite often, we give you the uncertainty. Quite often, because we just want to know, okay, if you have a bunch of measurements, do you know what to do with that? Do you know what to do with the uncertainties? And if you do, all you need to remember is add them. Okay? So don't go through this every single time. If it's provided, you're good, right? You don't have to do this step right here. So you can almost imagine, let's just imagine this was already there for a second. Let's just imagine this was already there. We went through it, but just remember this could be provided. So then we come over here and we're going to say, well, the first box is 16.5 kgs plus or minus 0.05. The second box is 2 kgs plus or minus 0.5, sorry. Gotta be careful. They're not all the same. And then the last one is 1.45 kgs plus or minus 0.005 kgs. So you have each measurement and its uncertainty like this. In this case, it makes sense to just add everything up on the actual measurement, and we always add with the uncertainties, always, no matter what happens on the left side. So when you add this up, I don't have this in front of me, sorry guys. I was already ahead of the game. 26. There we go. That's 1995. 19.95 kgs plus or minus. When you add this up, if you do it correctly, you get something like this, which is interesting, right? But that is my combined. So this is the combined weight with the combined uncertainty. Both things are there. Okay. This part right here is the combined uncertainty. So I would say this. Let's say the question only asks for this, and you give me the whole thing. If you label clearly and you tell us this is what the combined uncertainty is, you would still get full marks, as long as we clearly understand, right, that you know which one is the actual answer. So there we go. This is A, we're done. What's the maximum and minimum combined weight? So the max is 1995 plus 0.555, right? And the min is 1995 minus the combined uncertainty. And that amounts to 20.505 kg if you add it, or 19.395 kgs if you subtract it. Okay. So that goes for B. And there you have it, one more example.